All right, we're going to make a quick video talking about the 4 different cases with Hannah. So you have, Grace, you can put it right there. Thank you. We have 4 different cases. We could have, this is going to be a dy or dx if I make my cut this way.
dy.
Ooh.
What?
I'm making it perpendicular to the x-axis, right?
Mm-hmm.
So that's going to be a dx.
Okay.
When I go perpendicular to the y-axis, that's going to be your dy.
dy.
Yep, very good. Let me move this real quick. So this is going to be a dx going down, so we could have the line being above my curve. We could have the line being below my curve. We could have the line being to the right. And we could have the line being to the left. And again, what we're talking about is rotations around those lines. We could also rotate it around the x-axis or the y-axis. But these are the tricky ones. So here we go. So we're going to go, this is going to be a dx, correct? Because it's perpendicular to our axis. Now, which curve is farther from the line, the blue curve or the red curve?
The blue curve.
The blue curve. So the blue curve, the distance between my 6 and the blue curve is going to be the big radius, and between my line and my red curve, that's going to be my small radius. So you always want to work from top to bottom or right to left. So if I work from top to bottom, I'm going to do top minus bottom. So it would be 6 minus the blue curve. And what do I have to do to that? Do you remember, to find my radius?
Square it.
We have to square it. And then we do minus 6 minus my red curve. And then we're going to take the integral. Oh, what did I forget to do?
Square.
What else did I forget to do?
Pi.
Make sure that the pi, and it's a constant, right? So we can pull
Yes.
the pi outside. So notice we're doing the top, which is 6, minus the bottom. And then we have to think about which is the big radius and which is the small radius. Now here, the line is underneath. So again, we're going to cut it this way. Which curve is farther from my line this time?
The red curve.
The red curve. Very good. So now, instead of going 6 minus red, 6 minus blue, we're actually going to, how would we adjust our equation? This is a tough one. How we adjust our equation?
Like red minus -2.
Yeah, so it'd be red. Very good. Red minus -2. So that's actually going to be a plus 2, but I'll write it minus -2. And then what do I have to do to that?
Square that.
Square that. And should I be adding or subtracting?
Subtracting.
Subtracting, and then what would my next equation be?
Blue +2.
Blue, good, minus -2. Very good. Because again, we're doing top minus bottom, always, or right minus left. And then is that going to be a dx or dy?
dx.
Dx, because we're perpendicular to the x-axis, and then we got a pi out in front. Beautiful. All right. Last 2. So now we've changed it. Now are we talking about dx or dy?
dy.
Dy. And what's my big, what curve is farther from the line, the blue or the red?
Blue curve.
So the big radius is going to be, should it be 5 minus the blue, or should it be blue minus 5?
Blue -5.
So if
I'm sorry,
I did
5 minus.
yeah, if I did blue minus 5, I could do that, but I would get a negative number, and you would get a negative integral. So if you ever get a negative integral, you know you did it backwards. So it's going to be 5 minus blue. Wish I could write a little faster. 5 minus blue, and then square it, and then minus 5 minus red. Try to write fast. Squared. dy. We're going to take the integral. We're missing the a and the b, but you can put it out there, and then you got your pi. And then the last one, this is case 4. So now the axis of rotation is going to be left of our shape. So now what is this distance to the red curve?
Red minus -3.
Red minus -3 or red plus 3. Very good. And what's the distance to the blue curve?
Blue +3.
Good. And which one's bigger?
Red.
So it would be the integral of red plus 3, because minus a -3 is plus 3, squared, minus blue plus 3, squared, dy. Throw the pi out. Make sense?
Yes.
So those are the 4 different cases in 5 minutes. Pretty good. Nice. Thanks so much.
You're welcome.